Okay, we're just looking at the features of parabolas here. Sorry, I've got to check my volumes up. There we go. Going up. Hi there. We're just looking at the features of parabolas, and the U shape we know is a parabola, and the formula of the standard parabola that hasn't been stretched or moved at all is y equals x squared, and that's exactly what kind of parabola we have here. And any other features that we can comment on, I could tell you the domain of the parabola. So the domain is the x values for this parabola. As you can see, it stops at this point here and stops at this point here. So the x values only go as far as -3 and to +3. So x is in between those values, -3 on this side and 3 on this side. So we can say that x is greater than or equal to -3, and it's less than or equal to +3 between those values. And that's probably about all we need to say on that graph. We could also say that this here is the turning point or the vertex. The turning point is at 0, 0. And what colour? I'll keep it in blue. This means our graph is increasing here. Increasing when x is greater than 0, and the graph, this is decreasing in this way here. Decreasing when it's going on that kind of diagonal, it's decreasing. So those are the features of that graph. Let's look at another one. Let's go to the next. And my next one is the same parabola that was back on page 1, the pink one. You can see it's been translated, it's been moved across and up. I know it's a standard parabola that hasn't been stretched, because if I'm at the vertex, I can move across 1, up 1, across 1, up 3. That means it's a standard parabola that has not been stretched or expanded. It's only been translated. Now I need to work out how far it's been translated. When I want to write the formula for that, the equation, I have y equals x. Now inside a bracket, I can write how far it's going right or left. And it's usually the opposite of what you think. Being inside the brackets, you always think inside is always the opposite. So we're moving from 0, 0. This vertex started down at 0, 0, and it moved across 3 to the left. And so we're going to say that's going to be +3. Even though it's going kind of to the negatives, it does the opposite to what you think. X +3 squared. And then it moved up 5, so we do a +5. My head of department always says, what happens in the brackets is the opposite to what you think. It's like a woman, what happens on the outside is a man. But anyway, so that's the translation of that. And the blue graph is exactly the same, except because it's downturned, the top one's like a smiley face, it's positive. The bottom graph is a negative graph because it's a sad face, and the vertex again has been moved 3 across and 5 up. So x +3 squared +5. Okay, the next graph we can look at. Let's see what we've got. Okay, this bright green one. Now, is this a standard graph or has it been stretched? We can see from the vertex it goes across one, across one, up 3. So it's a standard graph. It's only been translated. And it's come 3 across in this direction. So it's going to be y equals x. Remember, it's going positive, but in the bracket it's minus 3 squared, and it's gone down 5, and so it's minus 5. And the other graph, the olive green, we could also talk about the domain of this graph. The domain of the bright green, it stops here and it stops here. So our x values, this is at x is 5 and x is 1. So the domain x is 1 to 5. X is between 1 and 5, so it's greater than or equal to 1, and it's less than or equal to 5. That's the domain for that graph. And the domain is the same for the olive green graph, but it's upside down. The vertex has been moved 3 across and 5 down. So we're going to have y equals a negative, because it's upside down, x minus 3 squared minus 5. Okay, let's look at the next one. This graph here, let's think about the black graph. Now, it's a bit more tricky. We can see it's been translated across 3 and up 5. Across 3 and up 5. But it now goes across 1, up 2, across 1, up 6. So it means it's been stretched or expanded. So we have a formula. We're going to have y equals A. A is telling us how much it's been stretched. And then we've got our normal translation. We're going x. We went across 3 to the left. So we add 3 squared, and we went up 5 plus 5. This is the black graph. But we need to find out what A is. And the way we do that is we find a good point. Now, looking at the black graph, I need to find a point that is, maybe I'll mark it in red. It's quite easy to see. There's probably one there. I could take that point. It's right on the cross. I could probably take that point there, or that point there. These are right. But let's take this one. It's negative 2 and up 7. Okay, so if I take the point negative 2, 7, so that's my x and that's my y value, and I can substitute it in the equation. So my y is 7 equals A, and my x is negative 2 plus 3 squared plus 5. Now you can work this out in your head, or you can put it in your calculator. So using my calculator, just so I don't make silly mistakes, I first of all choose equations on the menu. Turn this on, equations on my calculator, it's number 8. Then I choose F3, which is solver. F3. I can then write in the equation just as it is here. The A, I use an alpha, and just below the alpha there's the red letter A. I can put it in like that. When you've put that in your calculator, you must push execute twice. So execute once, we'll just put it into the memory. So you go execute, execute. and that comes up with a is equal to 2. Tells you your a value. So then I know my equation for this parabola is y equals 2 times x plus 3 squared plus 5. Okay, let's look at the next one. And again, you can have the domain. My domain will be between -5 and -1. My x value, x is greater than or equal to that, and it's less than or equal to -1. Graph we have, we'll look at the green one at the bottom. Again, when you see this, it's been widened, hasn't it? It's no longer 1 across, 1 down, it's 2 across, 2 down, and then it's going 1 across and some more down. So I know it's y equals some value, a. Again, inside my bracket, it's been translated. My vertex here has moved across 3 and up 5. So x plus 3 squared plus 5. And I need to put that point in order to find a. So I find a coordinate point. I could choose any. There's a good one there, right on the cross. That's -5, 3 is an xy point. This is my x, that's my y. So if I put this in the calculator, I'm going to say 3 equals a. My x is -5 plus 3 squared plus 5. Put that in equation solver, and you should be able to find that a equals -0.5, which is right because it's an upside down sad face, so it's a negative parabola. We've got one more. Yes, here's another one. This one looks like the standard parabola, across 1, down 1, across 1, down 3. So I don't need to find a. Y equals x. Now it's moved how many across? It's moved 3 across this way, so -3 in the bracket. It's gone up 3 plus 3, and that's squared. So that's my parabola equation for that one. The domain is where my x starts here and it goes to here. So that's x equals from 0 to 6. My x values are from here to here. They go between those lines. So x is greater than or equal to 0. It's less than or equal to 6. And last and lucky one, this black one here is across 1, up 1, cross 1, up 3. So there's no a in this one. Y equals, it's been translated. This vertex has gone from 0, 0. It's gone across 4 to the minuses, so it's going to be x plus 4 squared, and it's gone down 3, so -3. And our domain, the x values are between, what does that come down to? -8 and 0. So -8, my x is between these values. It's greater than or equal to that, less than or equal to 0. And that's the end of parabolas. Thank you for watching this. Bye.